Hello everyone, and welcome to Deriving Me Crazy Math Help. My name is Tori, and I will be your tutor today. And I want to wish everyone a happy math or treat, which is where we are going to talk about really hard topics in math. And this is one that makes up the bulk of calculus. It's the topic I'm introducing today, which is improper integrals. And sometimes, they may not seem like they're that hard, but depending on what form they're written in, they can be very hard. So this topic is a Calculus BC topic, and let's get started. So here, let's start out with the integral from negative infinity to positive infinity of e to the x over 1 plus e to the 2x. So first, one thing I would do with this problem is see if there's a way I can rewrite it, and I think it will definitely help us out to see things a bit better if we can rewrite it. So it might take us a few tries when we rewrite something too, so we have to keep that in mind in the future. So let's rewrite it as e to the x over 1 plus e to the x squared. This format may look a bit more familiar to you guys if you are familiar with arctan functions in Calc AB, which were they were in the format of 1 over 1 plus x squared. And in that format, you can kind of see the similarity between this and this here. Since this is the 1 over 1 plus x squared is pretty much the same thing as this, because your e to the x is serving as the x in this case, and the derivative of the inner functions up there, the e to the x. So that makes it useful as an arctan function. And that's kind of going to kick us off today and get us started on this problem. But before we start doing any more rewriting, we should definitely make sure we look at this limit here, or the upper and lower limits. Since they're both infinity, this is going to be more tricky, and it will require us to use limits such as negative infinity to 0, and 0 to positive infinity. These basically, if you add them together, they will give you the initial limit that we started out with. But since 0 is probably a more tangible value, and it's also a more convenient value for us, it will be the value that we are using. It'll just also look and read a lot easier by using 0. While this function is continuous, it's really just the convenience of using 0 and not having a almost doubly improper integral. It's kind of what it would feel like. And the 0 gives you something definite. So let's rewrite it again. So now we have from negative infinity to 0, and adding it to 0 to positive infinity. I would probably keep this in the format of the e to the x squared, because it will help you continue to see the arctan situation that is going on. And initially, you can be almost misled when seeing this, because it can also not really look like an arctan function. It just depends on how you write it, which might be easier for us here. So let's simplify it even further and actually take the integral of the function itself. So here, over here, our limit, we're gonna take the limit here as b approaches negative infinity. So we have from the limit from b to 0. It's just to help us write our integral properly. That's why we're using b instead of negative infinity. So now this can be rewritten as arctan of e to the x. And now this limit over here, or this integral over here, sorry, I can't fit it in quite well here. It'll be the limit as b approaches infinity. It's from, we're going to go from 0 to b for our limit, and it'd be arctan of e to the x. They're pretty much the same exact thing, just different limits is all. So let's continue. So now, so arctan of e to the, what is it? Arctan of e to the 0 and then we're going to subtract it. Arctan e to the b, or e to the negative infinity. So arctan of e to the 0, so arctan of 1, is, when I think of what the arctan of 1 is, kind of almost, you can set it up in a way where it's y equals tangent x instead of x equals tan inverse or arctan of y. So in this case, 1 is our y, so 1 equals tangent of x. So if you think about it, sine and cosine have to be the same, since you're dividing them. And the only situation in which that occurs is going to be pi over 4. And then arctan of e to the b, so e to the negative infinity, is going to be 0. Since that function, if you plugged in the limit as it approaches negative infinity, you're going to get closer and closer to 0. And now we're going to add it to, we're going to add this to the arctan of e to the b minus arctan e to the 0. So arctan of e to the infinity, so that format, if we think about it, is going to look like 1 over 0. So that would mean sine of something is 1 over cosine of something, which is 0. And if you saw my Instagram post recently about the trig, I think it was like the trigonometric kind of the, not identities, but the values. So like sine and cosine for like 0, pi over 2, how to remember all of them. And the unit circle, like those values. This was on there, and so this is going to be the point 0, 1 on the unit circle, cosine 0, sine 1, and that would be pi over 2. That's the value that has that for its tangent. And then we're going to subtract arctan of 1. So arctan of 1 over here, that was pi over 4. So that kind of helped us out. It saved us some time there. Now, pi minus 0, nothing, plus pi over 2 minus pi over 4. Pi over 2 can be rewritten as 2 pi over 4 if we're making common denominators here. So 2 pi over 4 minus pi over 4, that's just pi over 4. And then plus pi over 4. And that will give you 2 pi over 4 or pi over 2. So there is your answer, and I hope that this video helped you, and if you need extra help and would like me to go slower or want me to do notes or anything, please feel free to contact me on any of my social medias. Thank you.